Okay, so in example number 2, we want to find the function that describes radioactive decay. So given the half-life, we want to find the decay rate. So we're going to write our formula for that. Replace A by 1/2 of the initial amount, and replace T by the given half-life. And then solve to find K, and express K as an exact value, and do not round. Now, it is possible to find the decay rate using K, which is equal to negative times the natural log of 2 over T. Now in example 2, the half-life of carbon-14 is 5,730 years. We want to express the amount of carbon-14 remaining as a function of time t. So what we're going to do is we're going to use the continuous growth model formula, where the value of A is going to equal 0.5 times the initial. Now remember that what was given is the same thing as A, which is equal to 1/2. We're just going to write it as 0.5. And T, which is the half-life of carbon-14, is 5,730. So we're going to substitute the half-life for T in 0.5 times the original amount for A. So in step 2, we have 0.5 times the original, or half of the original, which is equal to the original e to the 5,730k. Now, if we divide both sides by that original amount, it disappears. And so then it doesn't disappear, well, it becomes 1. So therefore, we get 0.5, which is equal to e to the 5,730k. And so we're going to take the natural log of both sides. If we take the natural log of both sides, we end up with a natural log of 0.5, which is equal to 5,730k. And now, in order to solve for k, we can divide both sides by 5,730. So just flipping the order here, we get k, which is equal to the natural log of 0.5 divided by 5,730, which is approximately negative 1.2097 times 10 to the negative 4th, which is approximately negative 0.0012097. Most exercises want you to round it to either 5 or 4 decimals rather than leaving it in that form or in this form. So the model or the growth formula would be the following. So we can put it in this form where we just leave it as the natural log of 0.5 divided by 5,730. But again, as I stated before, 99% of the time they want you to write it in this form. So it's going to be the original amount times e to the value of k times t.